Okay, lesson 23. A little more review. Pre-cal trig type review here. And then tomorrow we get to talk calculus, I'm pretty sure. This isn't, tomorrow's derivatives.
Yeah, we're doing
Part of it, yes. We, officially tomorrow, I have not introduced the H notation. We've only introduced the delta X notation. But it's the same thing. So officially tomorrow I introduce the H notation, which is still the long way, but then we also start introducing a shortcut. I mean, there's bill-and-nons on the shortcut, and some of it just comes down to memorizing your derivatives. So I think it is, if I recall. Yeah, because it is a small lesson. I actually add a part D onto the bottom just to practice, but
that's what I do.
Yeah. And a delta X and an X are easier to get confused than an X and an H. I definitely agree. Yeah.
I've always used H because somebody in my calc book wrote like f of x plus h, and so ever since then I started using H.
And they've given you in some of the calc homeworks when they've been hinting at definition derivative and leading up to it, they use x plus h sometimes. And so, yeah. And me personally, as long as you're showing the notation, whether you use the delta x or the h, I don't care. I don't know. Honestly, I don't know if you'd ever have to actually work out a definition of derivative on a calc test. It's more where recognizing it in a multiple choice format that you'd have to be able, which I'll explain more of that eventually. But yeah. Okay. So the first half of our lesson today is trig functions of n theta. So for example, solving this first one, if that said sine of theta equals 1/2, it would be a little bit easier. But ours says sine of 3 theta equals 1/2. So we have to, process differently how we're going to do this because it's sine of 3 theta. Now, you will notice sine of 3 theta equals 1/2, and this is when theta is between 0 to 360. Now, Right. Okay. Now, with that in mind, let's see, I'm trying to remember where I like to start. Forget the 3 theta for a moment. Let's play the what if game, which we'll use. Okay. Of what if this just said sine of theta equals 1/2? What would your thought process be for solving that? What? Okay, you can think sine inverse, right? That would get you an answer. Okay, so yeah, you're asking yourself, at what angle does the sine equal 1/2? So the sine of what angle equals 1/2? So sine inverse would get you there also, because sine inverse of 1/2 would be the 30 if you're in the degree setting in your calculator, right? Now, officially, that's not the only answer of this problem, though. And this is where if you use sine inverse, it would only give you this one answer. So this is where we have to think, okay, on our unit circle, all the way around from 0 to 360, when does sine equal 1/2? So in quadrant 1, sine equals 1/2 at 30. Did he ever say it back there? No. Does that make sense? I'm gonna go through it in writing, okay? But his reasoning was good. Okay, so first of all, he never said this, but he alluded to it. All students take calculus, right? We already have, because sine is equal to a positive, we have our quadrant 1 angle of 30 degrees. We also need the equivalent angle in quadrant 2 because that is our quadrant where sine is positive. So, and this is the part where he was thinking, and this was the struggle at the end, if it's 30 degrees in quadrant 1, remember the equivalent angle is always that amount off of the horizontal axis. So that means we're going 30 degrees off the x-axis over here, and 30 degrees off of the x-axis is going to put us at 150, because 30 degrees up from 180 is 150, correct? Now, what about these bottom two quadrants? It's negative, so we don't have anything. Okay? And so it is 30 degrees and 150 degrees, and that's because those are my two positive quadrants, right? Now, so for sine theta, there were two solutions. For sine theta equals 1/2. We are solving for sine 3 theta. So instead of two solutions, got a guess? Not 3, more than 3. 6. Because there's two solutions on once around the unit circle. 3 theta basically indicates that we're going 3 times around the unit circle in a way. Or that's what we're kind of considering. Our answers, I'll get to it here in a moment. But yes, we are looking for a total of 6 solutions. Okay? So a total of 6 solutions. And if you want, you can think about, it was 3 theta up here, right? And so it kind of makes our range 0 times 3 is 0, less than or equal to 3 theta, less than or equal to 360 times 3 is 1080 degrees. So what we're looking at is our 3 theta, we have to consider those 3 times around the unit circle. So, first time, we're going to use these two answers right here, yes? And what we said is sine of theta equals 1/2 at 30 and 50. So 30 and 50 are essentially going in place of 3 theta. So we're going to take 3 theta and set it equal to 30 degrees and 3 theta and set it equal to 150 degrees. And that's going to provide 2 of my answers by solving those. Do you see what I did there? It says sine of 3 theta equals 1/2. Well, we figured out that sine of 30 equals 1/2 and of 150 equals 1/2. So that 3 theta is equivalent to 30 and 150. Now, if 3 theta equals 30, what's theta? 10 degrees. There's my first answer out of 6. If 3 theta equals 150, then theta is 50 degrees. Okay. That's time 1 around the circle. Okay. Second time around the circle. Go back to the original here. What happens to the 30 and 150 the second time around the circle? What is equivalent to 30 and 150 when you go another time around the circle? Yeah. Yep. So this time I'm going to do 3 theta, and I'm going to write it out as 30 plus 360. But yes, as I heard back there, it's 390. I just didn't want to write 390 and you look back later and be, why did I say 390? Because we took the original 30, adding the time around the unit circle is adding 360. So then up top, 390 divided by 3 is, oops, dang it. I don't want that in orange. Oh well. That answer is 130. And then we also have to take the 150 and add 360, right? 150 and 360 is about 510. And then if you divide, 510 divided by 3 is going to be 170, because I know 3 times 17 is 51. I'm up to 4 answers.
So let me guess.
What? Basically, these were the first time around the unit circle. These were the second time around the unit circle. We need to go a third time around the circle, unit circle, because it was 3 theta, right? So, you process it how you want. You could say, we did end up last time at 390. So, one option is you could take 390 and add 360, yes. Or if you prefer, because you didn't write that 390 number down or something, it'd be going back to the original 30 degrees and you're adding 2 360s. If you prefer that idea. Does that make sense? What, you're either taking, we had just gotten 390 in my middle step, so I can add 360 again to that. Or if you want to go back to the original 30, you're adding 2 360s. So 30 plus 360 plus 360. Whichever way your brain works to get there. 3 theta is 750. And so theta is 250 degrees. Stop me if you don't like the math I'm doing or if you're confused. And then my other 3 theta, I can go back and use 510 plus 360. Or if you don't like that one, it would have been what? 150 plus 2 360s. So, either way, 3 theta is 870, and theta is 290. Questions, comments, concerns? I mean, it's time consuming, right? You really have to process through it, but it's not, it's not outlandish. Okay, example 2. Now, first of all, last time, why did I do that problem in degrees? Because the range was given in degrees. This time, my range is given in radians, so that's indicating we're going to talk radians. What else is different? 4 theta. So that means we're going to have 4 sets of answers. If we have 2 initial answers, 2 times 4 is 8. Now that's based on assuming there are 2 initial answers, which usually there is, right? Because there's 2 positive quadrants, 2 negative quadrants. Okay, so starting block. We need to ask ourselves, when does tangent equal, oh, wait a minute, there's a catch here. Huh? Yeah, I almost did. Did you guys catch, I almost overlooked it. Tangent of 4 theta minus square root of 3 over 3 equals 0. This needs to be tangent of 4 theta equals, doesn't it? So, if you add that over, we're really thinking the tangent of 4 theta equals positive square root of 3 over 3. And what is this going to be on? If you multiply by 4, officially this is going to be on the range of 0 to 8 pi. Okay, So we are asking ourselves, when does tangent equal square root of 3 over 3? So get your quadrant 1 answer to start yourself. When does tangent equal square root of 3 over 3? Or wait, are you guys doing triangles?
I do triangles.
I go chart. Triangles work too, right? It doesn't, you know. And then to do tangent, remember tangent is sine divided by cosine, right? So this is 1. And these are the two I struggle with. Which one's which, right? One of them square root of 3, one of them square root of 3 over 3. So here, if I do sine divided by cosine, this one is 1 over square root of 3, which is, guess what? Square root of 3 over 3. This one is square root of 3 over 1, which is square root of 3. And again, triangles work too, right? You have your way. That's what matters at this point in life. Okay, so at what angle is this happening? Pi over 6. What other quadrants do I need to investigate? So we need to know this one down here. What is the pi over 6 angle in quadrant 3? Because it's pi over 6 past pi, right? Pi is 6 pi over 6, plus another pi over 6 is 7 pi over 6. And you guys already mentioned that we're going to have 8 solutions then, right? Because we had 2 solutions, and we're going 4 times around the circle. So theta is pi over 6 and 7 pi over 6. Okay. Do you remember what to do here? The first round, we're going to take our 4 theta, because we're looking at the tangent of 4 theta equals square root of 3 over 3. But we found 4 theta to be equal to pi over 6 and 7 pi over 6. So I'm going to say 4 theta equals pi over 6, and I'm going to say 4 theta equals 7 pi over 6. Okay, this is the tedious part, knowing how to do this. How do we solve for theta? Yeah. The gut says divide by 4, doesn't it? Then you realize, but I'm dividing a fraction by 4. So really what your brain needs to say is multiply by 1/4. So theta is going to be pi over 24 and, bless you, 7 pi over 24. We okay with the basic one? I mean, that's as basic as it gets here in this problem. Okay, now what? Okay, so, how many mistakes can I make here? 4 theta equals, and it was pi over 6. Up above we added 360. Here we're adding 2 pi. Now, when I say 2 pi, what is 2 pi in terms of sixth? 12 pi over 6. So really you're adding pi over 6 and 12 pi over 6 and getting 13 pi over 6. And we're going to take that 13 pi over 6 and multiply by 1/4. So theta is 13 pi over 24. And if you'd rather, you could continue doing the whole top row and then come back and do the bottom row, couldn't you? But in my bottom row, it was 4 theta, and it was 7 pi over 6. But if we add 2 pi, we're adding 12 pi over 6. 7 pi over 6 and 12 pi over 6 is going to be 19 pi over 6, which you are dividing by 4 or multiplying by 1/4. And so theta is 19 pi over 24. We okay with the math? Okay. Now what? Do it again. Good answer. So 4 theta equals, this is where I'd like to look back at the last one, right? The last one I put us at 13 pi over 6. So yeah, the easiest route in my brain, it didn't matter when it was just whole numbers, but when it's fractions, you want to make it easy on yourself. So 13 pi over 6 plus 12 pi over 6, which is 2 pi, right? So that's going to be 25 pi over 6. Multiplying the 1/4 over, and theta is 25 pi over 24. Bottom row, 4 theta is, let's see, where did we end up last time? 19 pi over 6. We're adding 2 pi again, so adding 12 pi over 6. And so 4 theta is 31 pi over 6. You multiply over the 1/4. 31 pi over 24. I don't know how far ahead of you guys are. How far ahead are you? Do you have them done, I'm guessing? Yeah. I'm going to work them out just so the work's here, and you'll discover some shortcuts along the way, won't you? And that's fine. Okay? But this is the math behind it. So now I was at 25 pi over 6, and I'm adding 12 pi over 6. So I'm adding that 2 pi again. So 4 theta is 37 pi over 6. So theta is going to become 37 pi over 24. Bottom row, 4 theta equals, we were at 31 pi over 6. We're going to add 12 pi over 6, so adding that 2 pi. So 31 pi plus 12 pi is going to be 43 pi over 6. You end up with theta is 43 pi over 24. Okay. Got it?
Do you mind if I can have like a moment, 30 seconds?
Nope, you're fine. Nope, you're fine. Listen, there's shortcuts and stuff you can find in there along the way once you see what's going on in within a problem, but, you know. Because like in this one, if you follow the pattern, we ended up adding, 12 pi over 6 in between each of them? This one up here, we added 120 in between of them, because it's a matter of how far apart the angles are. 30 and 150 were 120 apart. Pi over 6 and 7 pi over 6 were a pi, right, apart. So, okay. Okay. We keep going back to these conics in different ways, right? You know, we've talked about them in several different ways. This one is using a calculator. Can you graph the ellipse defined by the given equation? Well, you hear the word calculator and graphing, and what do you know? So we need to take whatever equation they give us and solve for y. So we are given x squared plus 2x plus 4y squared equals 15. I said 15.
I was going to say, you put 150.
I wrote 150. That's the pen's fault. The pen wrote the extra 0. I had nothing to do with it. Okay, so you guys know what to do here. Tell me.
So, subtract x squared and 2x over.
Okay, if I want to get, there's only 4y squared, that's my only y term. So we're subtracting over, or moving the other terms to the other side. So I already have 15. I'm going to subtract 2x, subtract x squared to the other side. I wrote mine like this. It doesn't matter the order you write it in. Okay, we're going to, since it's 4 times y squared, divide by 4. Now, we're getting ready to put this in a graphing calculator, right? Because we're dividing that whole side by 4, which means you can go divide each term by 4. Or what I'm going to do, I'm going to make it one big fun fraction. 15 minus 2x minus x squared all over 4. And here's what I'm looking at. When I go to plug that in the calculator, it's going to be easier that way than having to plug in a fraction plus a fraction plus a fraction all underneath the square root. Oh, I gave my next step away. Square root. Because it's y squared, we're going to take the square root. And what is y equal to?
Square root of square root.
Okay. So I wrote a couple of things in here based on various people I heard and what they said. Ross talked about the fact that I can take the square root of 4, can't I? So we can do this as one big square root where the fraction's under the square root, or you can do a square root on top, all divided by a regular 2. Ethan threw in that when we take the square root in an equation setting, we need a plus or minus. How am I going to enter this on the calculator? So, time saver is y1, you make your actual graph. And this is because this only works when it's just one big term that's a positive and a negative version, right? So you can say the square root of, 15 minus 2x minus x squared all over 2. And then you can also say y2 equals negative y1. Now, if you'd rather type it both times, you can. And if there's other terms added or subtracted that aren't the exact opposite terms, then it doesn't work. So I'm going to do a fraction bar, a square root on top. That's my y1. You can't see what I just typed, sorry. Square root of 15 minus 2x minus x squared all over a regular 2. And then I'm going to say the negative of y1, which is F4 menu, if you have your F4 menu. You can do them right there. I know there's somewhere else too. I just don't know where off the top of my head. I really don't know where. Oh, I bet. There we go. So if that doesn't work, these are variables, right? Like when I go into my alpha F4, it's vars, VAR, or something like that. So if I would have gone into vars, which is a button next to clear, and I go over to yvars, and we're working just regular functions, there is your y1 through whatever. So I knew they had to be there somewhere. Everything's there somewhere. Okay. Zoom 6. Remember, this one actually lined up pretty well. Sometimes they kind of line up goofy, don't they? So, did we get it figured out one way or another? And it does say use the graphing calculator to graph it. So to me, that says I'm going to sketch a graph. Okay, it looks like it has an x-intercept of 3. And maybe negative 5. And y-intercepts of approximately 2 and negative 2. Something like that. And again, I'm off the screen. We have one more on the back side, don't we? Yep. And just for reference sake, that was a Zoom Z standard, which means my graph is a little disoriented, or not disoriented, out of proportion. This is Z square that makes it more in proportion. It looks like an ellipse both ways here. Okay. One more. Maddie just found something exciting. Or did something bad, one of the two.
You can change the... Nothing. It's nothing. It's really stupid.
She was excited. You changed the color or something? Or?
Yeah, the graph. Because you can do light blue, and I didn't know that. I got really excited.
Yeah.
Anyways.
You're new to this calculator, so I'm like,
wow. Step up your game, Ron.
I thought about briefly during the summer of purchasing one of the fancy fancy ones.
Oh,
you should have worked a deal with Jace to get his.
Well, I was going to, but then come to find out, Jace already gave his drafting calculator to Gavin Hoffman.
He did, yep. So I've charged it a couple times for him. So, yep. Okay. One more example. Graph the conic defined by this right here. Hey, pop quiz. What is this going to be? Falls into the ellipse/circle category because x squared and y squared are both positive. They're the same numbers, which falls into the circle category. Okay, good. Okay, so x squared plus 4x plus y squared minus 2y equals 4. Okay, thoughts?
So can we get all the y's on one side and then just factor out a y?
Yes, we want all the y's on one side. No, we're not going to factor a
So
y.
you factor it out, you still have y minus 2, which you still have to divide by y.
Because we can't, and if you're trying to think like set both pieces equal to 0, it's not a 0 on the other side. So, okay, so I'm going to keep my y squared and my minus 2y there. I'll leave a gap. On the right, I have a 4. I'm going to subtract over 4x, and I'm going to subtract over x squared. Because the difference between this problem and the last problem, last time it was just a nice, neat y squared term. Piece of cake. Not a piece of cake when you have a y squared and a y term. Okay? Factoring the y out, common thing we want to try. It would be good if this side was equal to 0. Because then we could set both pieces equal to 0, or, you know, if you're trying to solve it. But in this case, I need this to become y equals and not end up with a y over here. So, I gave you the hints, didn't I? 1, negative 1 squared is 1. If I add 1 on the left, you're adding 1 on the right. The whole point of that process is the left can now factor into a perfect square. Square root of y squared is y. Square root of 1 is 1. Middle sign is a negative. Or what number multiplies it by itself to be 1 and adds to be negative 2? If I clean up the right, 4 plus 1 is 5. So 5 minus 4x minus x squared. Yep. Square root first, because that's my outer function. So then I'm going to have y minus 1 equals the square root of 5 minus 4x minus x squared. That has to have what in front of the square root? Plus or minus. And then if it's y minus 1, I'm going to add 1. So y is, I like to write this as 1 plus or minus the square root of 5 minus 4x minus x squared. What are options for typing this into the calculator?
Also adding 1, you could just do the negative, right?
Correct.
You have to type both.
I don't have a shortcut for this one. And it's because of that 1, right? It's not just plus the whole side and minus the whole side. That 1 is positive in both cases. So I'm going to have to do 1 plus the radical and 1 minus the actual radical. Okay, interesting. So, ideally, that's probably your best bet, right? If you're really against, and honestly, this was just as much work for me, if you're really against typing the square root 2 different times, here is my... So what I did is I made y1 just the square root. And then I made y2 1 plus the square root, and y3 1 minus the square root. Now, because I don't want my graph to be confusing, I don't know if we've ever talked about this. Notice these two, they have that little like highlighted equal sign. Up here, I went up here and I hit enter on that highlighted equal sign and turned it off. What's going to happen now is y1 won't physically graph. It's just in there. y2 and y3 are the only things that will graph. So you can turn a graph on or off, like one of your lines on or off. Does that make sense? And I don't know how much I've ever addressed that, but no, how it's helpful is if you're doing a homework with a whole bunch of graphs and you have a graph in, you want to ask a question about the next day, so you don't want to delete it out, but you still want to keep going on your homework, right? So you can turn graphs on and off by just highlighting, unhighlighting that equal sign. So, if you do a standard Zoom 6, you get that, which looks like an ellipse. But if you zoom square, number 5, we talked about that, I know, right? Zoom square gives you does your circle look kind of lopsided like that? Or is that just mine?
Mine kind of does, and it also doesn't.
Yeah. Mine doesn't really join together on either side, technically. And there's a bigger gap on the left than the right, which makes me think I typed something wrong, but I don't think that's the case. It just, you have that lopsidedness too.
Yeah. It's like there's a pretty obvious,
Yeah. But technically, it's just graph or failure, right? It is a circle. It does technically connect. It just doesn't always connect very well on the calculator. So. No, it doesn't. And that is the difficulty of you can't really get like, I don't know, those farthest out values where it's supposed to combine, you can't really get those using the calculator. You can guesstimate them, but you can't really get them. So let's see. I don't know. It looks like we maybe crossed to about 1 on the x-axis, about 3 on the y. What is that, almost -5? On the x, somewhere between 1 and 2 on the y. This circle is not going to look good. Yeah, I can't draw circles like that when I'm trying to get, I can't do it. So.
That looks better than mine.
Okay. Get what you need from there. You guys probably already have it.
We've been doing